Good morning, everybody, and I welcome you to the 8th session of the training in quantum technology that 𝐀𝐠𝐞𝐧𝐝, the coordination action of the quantum flagship, offers to the policymakers. As always, a little introduction about who we are and who you are actually. Let me just share my slides. And today we are going to talk about the state of the art of quantum technologies, and in particular in Europe. And I'd like to remind you that in the past 7 sessions, we had a very interesting journey, which brought us from the ecosystem in Europe through the international collaborations and the state of the art worldwide. And then we have passed through several use cases, and we had a lot of insightful presentations about quantum sensing and metrology, where we learned that we can now practically make a map of the gravity, thanks to the gravitometers, we can make a map of the level depth around all the Earth and monitor it in an indestructible way, much better now. And then we heard also about the quantum metrology and quantum computers, who are developing fast and fast, but still we are on the race to find the materials, proper materials, and ways to build a universal quantum computer. Then we also talked about the simulators, which are stronger and stronger, and they help us to simulate already some very interesting materials and some very interesting insights for catalyzers. And last but not least, we also talked about quantum communication, of course, and we learned about the networks we have already in Europe for start of the quantum internet. And today, what we're gonna talk is that the future cases of tomorrow, practically, which is currently the state of the art, maybe in the research and development labs, and tomorrow is gonna be a new use case. And I'd like to bring your attention that we will have one more special session, although this was going to be a final one, but we were very excited to get an opportunity for inviting to the stage a coordinator of another interesting coordination action, which is called gender action. And we will get news about how the action and the gender balance flow is spreading in Europe. And in addition, we will talk about other challenges for quantum technology in Europe, which are societal challenges in this case. So we'll talk about inclusion and ethics and widening. It's going to be very exciting. Please remember, we plan it for the 23 June, but you will get, of course, an announcement. Quick bio of who is working on this training. So we are a team of 3, and we work in the National Research Council, and in particular in the National Institute of Optics, under the lead of Professor Costanza Toninelli. So it's me, Dr. Oxana Mishina, who is being a postdoctoral researcher, and we have Diana Tartaglia, who is doing her PhD thesis on the impact of communication about quantum technologies to society. And we thank the whole group of 𝐀𝐶 for their collaboration and preparing the training and the program. As always, we hope that you gain knowledge to take informed decisions from these trainings, and that it will help you to cooperate with peers from other countries, and of course, sustain conversation with us fellows experts on quantum technology developments. And a little look back on who we are. Generally, there are a lot of people who register. Today we have 151 registered people. We'll see how many will show up. But just to let you see that the people who connect are from many different countries. So we cover the 27 EU usually. And then generally people are very well updated and they keep themselves up to date. And this is what we are providing here. So today, as I said, we're going to talk about the state of the art, and we're going to talk about infrastructures that we have in Europe that are going to help us provide future use cases. And we will also talk about the strategic and technology and industry agenda for the Europe. So the first speaker that I'd like to invite today is Professor Francesco. So my stopped moving my slides. I'm very sorry. Professor Francesco Cataliotti, and I'd like to ask him to come up. This is why it's hidden. To come up on the stage. Welcome, Francesco. So just a second, I need to. Here we go. And I'd like that your biography shows on the side. So I'd like to and which the name is just wrong, so I better hide it. And I apologize for the inconvenience. So we stop showing my screen. Oh, so it's against me today. The whole world is against me today. But we have great operators, so we'll cut everything out. And how do I make it open? Okay, I don't know. My Zoom went in tilt. In any case,
well, don't worry. Don't worry, since we're going to talk about the quantum communication infrastructure.
Could you please put up your slides so that mine
yes,
go
of course.
away? Because there is something I cannot access Zoom anymore. Something has happened. Okay, stop sharing. Here it is. Okay. Okay. So I welcome Francesco once again, and I will still like to read the biography of him because this is very interesting piece of information. So Francesco is a full professor of the structure and matter at the laboratory at the University of Florence in Italy, and he holds the membership in the board of the Atomic, Molecular and Optical Physics Division of the European Physical Society, as well as in the Research Council of the European Association of Meteorological Institutes. So his research revolves around the physics of atoms and their interaction with laser radiation. So practically all we can imagine about quantum optics. He has taken charge of numerous European projects concerning quantum technologies. And notably, he represented Italy in the FET Flagship Board of Funders and in the board of the European Quantum Communication Infrastructure. So since 2021, he has held the position of director at the National Institute of Optics of the National Research Council, and overseeing CNR's involvement in the quantum technologies initiatives and in the Italian National Recovery and Resilience Plan. So, Francesco, you are very welcome, and we are grateful to you that you accepted our invitation to speak about the European Quantum Communication Infrastructure, EuroQCI. The stage is yours.
Thank you very much, Oksana, for your kind words and for the invitation, and to you and the whole team for organizing this very successful series of events. That is very, I guess, I understand, extremely important and very useful. So let me just start right away by talking about a bit about what is the European Quantum Communication Infrastructure and how we got there. I will, since I guess this is for policymakers, this was everyone's favorite, and I'll try to explain why this infrastructure was everyone's favorite at the EC and with the member states. So just a first hint. This is the usual slide that most of us show about the European quantum fleet now, that started with, of course, with the quantum flagship, and then was enlarged to include new activities, and in particular, infrastructures which are the European Quantum Sensing and Metrology Infrastructure, the Quantum Computing and Simulation Infrastructure, and what we are going to talk about this morning, the European Quantum Communication Infrastructure. And of course, you know that to get here, we had to start, and we, as has to be the case for all advanced technologies, we started from amazing and fundamental science that is financed in the European programs for the European Research Council, and I'm just trying to get a pointer, and within the Marie Sklodowska-Curie initiatives, and also financed among member states with the Quantera program. Now, the European Quantum Communication Infrastructure is a program that promotes and contributes in Europe different things. Here are, let's say, the more upstream points. So it promotes national and European security strategies. It promotes the European industrial strategy, and it promotes the development of a national and European infrastructure, which is for a secure strategy on quantum communication, both on the ground, which means fiber, and in space, which means satellites. And this comes from a declaration of intent to collaborate on this between the European Commission, in particular Commissioner Viola, here holding the declaration that was signed in Budapest during the Digital Assembly on the 13th of June 2019, and a certain number of countries. I will then tell you a little more about the story. And you see that the quantum communication infrastructure started let's say, as an important critical infrastructure that is for sure aimed at security of all the strategical assets of the European community, but also it's a long-term scientific and let's say it's a technological dream that is the quantum internet. So once we change our background technical basis from classical to quantum, computers will go into quantum, sensors will go into quantum regime, and we need a quantum internet. The EuroQCI has the ambition to start that. It has a quite large portfolio of research projects. These are research projects that started within the Horizon 2020 and the Horizon Europe, and a lot of studies for the architecture that were led by different companies. These are research programs. These are funded studies led by companies. And of course, its main heart is within the Digital Europe program, and it consists of 26 national deployments, so one per country. So in each country there is an infrastructural deployment and 6 industrial development projects in order to produce the technological assets, meaning all the systems that are needed and the devices that are needed for implementing the quantum communication infrastructure within Europe. And after all these 6, there is also a coordination and support action that is Petrus. Just a second. Okay, no, I don't see my bottom, but so I'm unable to point it out, but it should be down here. Further, we will go on to implement the cross-border implementation, which is both in fiber and satellite, and the SAGA project, which is a project of the European Space Agency to put in orbit a series of quantum-ready quantum communication satellites. So this is the entire ecosystem of the European quantum communication infrastructure, and I would just conclude my few minutes just telling you how we got here, and because this is something as an Italian I'm particularly proud, because it was our representative, Professor Valditara, during the Vienna, the launch of the quantum flagship launch in Vienna in October 2018, that put forward this idea of an effort to create an entire network of quantum communication channels covering the entire Europe and connecting to its islands as well. So this means a global network. And this, the point also I think that is important here is that he made was that he shifted from the idea of the need to protect the data that could be seen as something not necessarily positive. You want to hide something to instead what it's really at the heart of the whole thing. The fact that if you are able to share information securely, this is the heart of democracy. Basically, the ability to share information without these being hacked is a fundamental asset in a democracy. And this meant that this initiative was really immediately embraced by all member states and the Commission. First, because it's a positive value for the quantum technologies. Second, because it's it implements a technological dream, but goes into very precise services that one wants to implement. And third, because it's an infrastructure that is diffused all over the continent. It means that each country has its own piece of the infrastructure. So these, I think, are the three ingredients that made this kind of infrastructure an immediate success. You see that just from October, 3 months after, 5 months later, we were already putting together a working group and we signed the declaration in June, another 3 months. And nowadays, we have the infrastructure in place. It's starting to be developed and it's going to be implemented within the European Secure Connectivity Program. So I think I went a little too long, but this is a good starting point, I guess, for the next talk. So I thank you for your attention and I will be ready for questions later.
Thank you very much, Francesco. And it was great to hear the news from the EuroQCI. Formidable. And we will collect all the questions in the question and answer chat. Please write them there and we will then address them. We will have half an hour in the end for the discussion with both the speakers. So thank you, Francesco. And I invite our next speaker, Salvatore Cinà. So I will try. I hope that this time my slides will not betray me, and I will manage to introduce Salvatore very well. Okay. So we are very glad that Salvatore accepted our invitation. Thank you very much. And Dr. Salvatore Cinà is the Program Director of Quantum Technology at CNR-INO, which is the French National Energy Agency. And he was previously responsible for the technology transfer and for establishing and managing strategic industrial partnerships. Earlier in his career, he served as the deputy head of the optoelectronics department at CNR-LETI. I don't know if he will mention to us what it is especially today, and as well as the executive director for the 3V Lab, a joint venture between CNR, Thales, and Nokia. Okay, that's a really great venture. As a scientist, he conducted research at the University of Cambridge on poly-Si-thin films, transistors. So, and at the Toshiba Cambridge Research Center on the, now I need to ask Salvatore how to read it correctly.
Yeah, 3.5 semiconductors.
3.5 semiconductors devices. Thank you, Salvatore. At Cambridge Display Technology on organic-based optoelectronic devices, and at Thomson on the development of OLED-based displays. And then Salvatore has a degree in physics from the University of Rome, alma mater, as they say in Italy, and a PhD in semiconductor physics from the University of Cambridge. So I wonder which companies on earth Salvatore did not contribute to. They're probably not. And we are very happy to welcome Salvatore to present us a piece of art that he orchestrated, which is the strategic research and industry agenda for the quantum technology in Europe. The stage is yours, Salvatore.
Okay, so I will share my screen. Can you see correctly the introductory page?
Yes, it is all in order.
Excellent. Okay, so thanks, Oxana, for the invitation, and good morning, everyone. It's very nice that there are so many people attending these training sessions organized by the Commission. So what I'm going to do today, so I will share with you today a short overview of what the strategic research and industry agenda is, and the reason why it is an important document for Europe and for the Commission. So first of all, I'll just an overview of what the ecosystem, the landscape in Europe looks like concerning quantum technologies. For those of you who are not extremely familiar with this. So when we talk about quantum technologies, we talk about essentially four main applications, which go in essentially computing and simulation, which are two facets of the same business. Then communication, which has been introduced by Francesco, and sensing and metrology, with a basic science, which is one of the 5 pillars in the way has been always presented in Europe so far. You should know that, for instance, all the cyber encryption is not included in this the post-quantum cryptography is not included in the current landscape in Europe. So starting from this, which was the initial structure, we had a lot of other initiatives that started evolving, as Francesco said, also in this evolution from basic technologies into infrastructures. So EuroQCI, you heard about Francesco, who presented EuroQCI about with the quantum communication infrastructure. There has been a similar evolution, then starting integrating at the system level what was going on at the more fundamental research level in this pillar, so about sensing and gravimetry. There has been, and is becoming very relevant today, HPC, so the way quantum computing and simulators are integrated within the high-power computing infrastructure as an accelerator to create some hybrid approach to computing. And more recently, with the first calls in end of last year, the CHIPS Act is playing a very fundamental role in the implementation of Chips for Europe, where there is a specific section for quantum chips. And then there are other initiatives like skills and education, which is becoming critical because, I mean, in Europe now we have a strong requirement for competences that is becoming larger than what the universities and the research centers are producing. And there is also a now very well established consortium that puts together all the industrial companies and startups in Europe that deal with quantum, which is called QUIC. So this is what the ecosystem looks like, and the quantum flagship is now has been given the mission by the Commission to make sure that in the way we do research and we exploit and we go at the system level, we make sure that all this ecosystem that has been evolving at different levels it gets aligned. So essentially, if I take the same slide that has been presented by Francesco before, because it's relevant for the discussion for the SRAE, we started doing research with an initial document published a few years ago, was called the Strategic Research Agenda. It was essentially talking about strategic research, so fundamental research and the way and focused on technology. Then a couple of years ago, we started financing by the FPA and the FGA, the first pilot lines and the first testing facility, QPilot and QTest. And then as I mentioned, QUIC started publishing a strategic industry roadmap. There was the second version published in January 2024, so just a few months ago. And then all these infrastructure initiatives. Francesco presented EuroQCI, and they've got their own roadmap, their own document, saying what they are expecting from classical communication infrastructures and quantum in order to implement the first solutions, which is the quantum key distribution for quantum cryptography. Then EuroHPC, as I mentioned, they also got their own roadmap which materialized in a document called HPC-QCS, so how to include quantum computing and simulation within the HPC infrastructure. And as I mentioned, the European 𝐀𝐠𝐞𝐧𝐝𝐚 that have got their own SRIA, so their own strategic research and industry agenda. So all this had to be put in a coherent way to make sure that what we are doing here in research is aligned with all the other initiatives, because when we develop basic research for the communication, sensing, etc., has to be aligned with the way the infrastructure and the roadmap the infrastructure has to integrate it within. So this is the reason for moving and developing the strategic research and industry agenda. We're essentially to put a coherent view of all the agendas and roadmaps produced by all the initiatives in Europe, and essentially on top of the 4 pillars that I mentioned at the beginning, so the 4 at the middle, has to include all the other transversal activities that are extremely relevant to make sure that quantum succeeds in Europe. So on top of this defining at a very detailed level what should be the roadmap and for the 4 pillars. We have also discussed, basic science that was already there, but also the engineering enabling technology. You need lots of classical technology in order to make quantum work. From the cryogenics to driving electronics, most of this stuff is classical and is required in order for quantum to work, packaging. You can list plenty of them. Education and workforce, as I said, we have a challenge today in developing the competences and the skills in order to implement the roadmaps and the strategies of all these initiatives. So one way, and the recommendations are to, of course, you have to implement new courses at the university and doctoral level, but also you have to implement and move in skills and competences from people who today work, for instance, in semiconductor physics, and they can move into quantum just by learning new skills. So those who have been developing error correction competencies in telecommunication, they can move in error correction for quantum computing. So there is an effort here that has to be pushed in order to develop the skills in all the possible ways. Standardization, which is linked to intellectual properties, because we want to make sure that we are participating at the national and at the European level in all the standardization initiatives, and that the IP that is being developed reads into the standards. And also that together with the standardization, we are pushing and we are pushing the benchmarking that are say, supporting the solution that have been developed in Europe, and not just following the standards and the benchmarking which are being pushed by the US or by China, for example. Funding is an important problem because you get funding from Europe, you get funding from at the national level, you get funding for research, you get funding for startups and for industry in order to industrialize the solution. All these has to be coherently aligned, mainly for research at the national and at the European level, and at the VC level and private investment for companies. We have to make sure that we compete with the investment which are done outside Europe, meaning we have to push startups up to high level of investment if they want to compete with the Google, the Facebook, and all the giants that are growing up outside Europe. And this is linked to international collaboration. We have to identify and develop bilateral partnerships with countries outside the EU 27 that are partners with whom we can create dependencies and reduce the barrier in order to industrialize the technologies developed in Europe. social and ethical values are very important. I mean, we are talking about equality, we are talking about making sure that today the opening and widening to other countries gets effectively pushed so that we do not limit technologies to those who are already leader in Europe. And this can be done in a very simple way. I mean, in terms of guaranteeing equality, if you are ready, I mean, implement simple rules like making clear in some conduct code, in conference, etc., there must be equal representation. You will avoid having biased panel sessions or conference which are guided by only one group of people or one part of the society. Communication is fundamental because, I mean, if we want people to understand why we are doing all the stuff, we have to influence and communicate to the broader community as well as to the scientific community to, as I say, to make sure that people can move from what they're doing today into a new activity which is related to quantum. And the governance is to make sure that all the stuff that I mentioned before in Europe is handled correctly, and there is a transversal governance that aligns European activity with also what is done today at the national level. So these are the chapters. All these chapters are developed within the strategic and industry agenda, which is a big document. It's a 300 pages document. You can download it from qt.com, as I would say at the end. And of course, I mean, I've gone on this because, I mean, the pillars, of course, I mean, each chapter addresses for the pillars and for the transversal ask and answer the same question, meaning what are the societal challenges that we are facing today and what are the opportunities for quantum. And then once we identify these, what are the challenges in terms of scientific and technological industrial challenges in order to make sure that we can address those who are the origin of the reason why we are doing this work. And together with the scientific, as I mentioned before, all these transversal challenges that I've been just describing, education, IP, etc. So this essentially explains what are the issues and what we have to do in order to make sure that we are tackling them correctly. And then the actions, what we have to do in order to address the challenges. And so this is what is important for the Commission, and is to make sure that we can translate this into action with objectives and recommendations. And this will drive the future goals and the future program that the Commission will publish in the coming year. So it's a quite relevant document, and I say it's important that it is aligned with all the others within Europe. It's been quite a long work. I mean, I've been coordinating this, but I've not done this alone. I mean, there has been a core team with Philippe that sees there today at the school. Lots of people have participated with links, as I mentioned, from the most relevant initiative, HPC, QCI. In this case, Deutsche Telekom was representing Petrus. There was the coordination and support action in EuroQCI. So we made sure that there were clear interfaces with all the other initiatives at the system level in Europe. And then the work was done chapter by chapter, coordinated by one person. You can see there is a broad representation, and these people here have been coordinating a working group. Essentially, altogether, more than 300 people, scientists within Europe, contributed to this document under these working groups led by different people with the job of essentially consulting these people with the question I mentioned before, consolidating this, and then making sure that all this content was validated and it was fairly representing what Europe was the mission for Europe, and not just for the entity that we're representing. So the process to make sure that this was done correctly was done in few steps that I'm going to just say. Initially, I mean, we just had to merge the initial document that I mentioned before. We published a preliminary document at the end of 2022, just saying what was existing. Then, as I mentioned, we created these working groups. It took a bit of time to identify people willing to contribute, fairly representing the community, the 27 countries at the different level. And then we started this consultation. We produced a first draft of the SRIA mid of last year, and then then we went through another broader consultation. So on top of the working groups, we have consulted the Strategic Advisory Board, that is the coordination with the governance for the flagship, the Quantum Coordination Board, essentially giving access to all the project leaders and to all the projects within the European program to what the SRIA was saying. The Quantum Community Network that makes the link with all the national initiatives for the 27 countries. QUIC for the industrial ecosystem, 𝐀𝐠𝐞𝐧𝐝𝐚 I already mentioned, DG Connector was involved in the broad consultation, again the working groups that previously contributed to the initial draft. So we went through another round, and then we presented this the SRIA during a panel session in Hanover in October last year. So we shared this with a large number of people attending the conference. The document was finally validated in December and it was published on the 14th of February 2024. You can now download it. It's free for everyone, and you can find it in the page qt.eu. And that's really what I wanted to say, and that just to share with you the steps. I mean, I'm not worth going into any more details about the document. Then thanks a lot to all of you for your attention.
Many thanks, Salvatore. This was a barely impossible task to represent the strategic research agenda in such a short time, but I think it will pay us back that you managed, and we will get a lot of questions. Actually, we already inundating questions, and I would welcome back Francesco, and I'll kindly ask you, Salvatore, to take away your slides, exactly. And this is the exciting time. We have good 20 minutes and we can discuss a lot of interesting things now. So we have collected questions in two different ways. One was via the registration link, when people could already express their curiosity while they were registering, and the other via the direct question and answer link. So I will start with a couple of questions which are fresh now from the audience. And the first one will be from Ferdinand Christorn from Netherlands, and the question is the following: how will we advance from open science towards the confidential networks needed for governmental applications, and the security indeed in the case of safety actors on the European and national levels? So I think that Salvatore or Francesco would probably take the first peek on that question, and then maybe Salvatore adds on his opinion.
Okay, so I get, if I understand correctly, the idea is we start, of course, with a very open scientific endeavor where there is a full collaboration between partners within and outside Europe, which is essential for science, and it should be maintained. But it's clear that at some point along the line, and there is quite some strategy, and I think probably Salvatore can add something on the agenda. There is some strategy where you get into a more, let's say, closed environment. For example, within the European quantum communication infrastructure, the technological means are certainly safeguarded within the European ecosystem. Now we have restricted from the whole world to Europe. And then, of course, you go for the protection of certain data. This is the, let's say, the security part. What is fantastic about quantum key distribution and quantum communication is that it's secure per se, it's physically secure. So you don't need to have a separated, different infrastructures to have both the open exchange and, for example, create not exactly the same, but it's not too different. It depends on how we will be able to implement the quantum repeaters. Those are really the core of what would be available if we could do the quantum internet or not. If we could do the quantum internet, we will have both the open part and the secure part together, because there is no problem with that. It's physics that guarantees that they are separated. I don't know if I explained correctly. I don't know, Salvatore, if you want to add something.
Well, I can probably add just a few words with respect to what you said. You mentioned the quantum key distribution is protected by the law of quantum mechanics. By essentially, if someone observes the key, it can be spotted, and then the key can be discarded. So intrinsically, it cannot be any interference can be detected. But anyway, despite the law of quantum physics say there is fundamentally and intrinsically resistant, nevertheless, within the project that we are developing at the national and the European level, we are testing this, meaning that we are doing some black box tests in order to make sure that within the constraints we have today, in terms of the bit rate, etc., we are already testing that that effectively it is as resistant as physics says to us, though there is an activity that is part of the standardization and part of the certification process that is by people who are used to do this as business and at the pre-certification organization in every country. This is what they are doing. They are testing. They are doing black box attacks into this system. And when they spot an issue, it will be introduced and it will be dealt at the national and at the European level in order to make sure that this solution is found and importantly has to be implemented at a standardized level at the European level. Otherwise, so this is a loop. And we are in the initial experimental phase of this loop today.
Very nice. Thank you very much for the response. And let's try to go on to questions that are more about technology, just for a bit. And we have one from Raja Ryan. He's asking how quantum upgraded electrical systems of tomorrow can facilitate renewable energy integration. Nobody says the answer exists, but we try.
No, but the issue, I mean, I can probably try to answer this one, but when we say that quantum it will play a fundamental role in the energy transition is because of the complexity of the new network, which will be based on a mix of renewable and existing traditional sources, nuclear, and progressively disengaging from carbon base. When you get supplies which are intermittent, like solar and wind, together with a generation and consumption curves that do not match, you need to strategically define where you want to introduce your storage. Can be hydrogen, can be batteries, and based on a real-time analysis of generation and consumption, you have to understand whether you want to discharge in a place and put the storage in a different place. So if you want to anticipate the generation of energy in a given area because the weather forecast is announcing a decrease in solar energy, I mean, the more the system becomes dependent on intermittent sources, the more you want to rely on the existing storage that can be cars and batteries. The more the system becomes complex, the more in real time you have to analyze extremely complex scenarios, and this is where the limits of the classical computing is. If you get an exponentially complex system with a larger number of variables and you want to quickly in real time understand what is the optimum solution so that you can direct your energy, your storage in the right place to make sure that your transmission network is not exploding and that there are no failure in terms of energy in a place based on what they will be expected to need. This is what quantum will bring. Quantum will bring essentially in this logistical and a complex multivariable world that will become more and more complex. It will bring the computing power that is fundamentally required in order for the system to be handled with a quality of service that would be required for a society like ours, to get continuous flow of energy. And today, if you want to do it also in an energy efficient way, quantum would be more efficient than classical, but always working together. I mean, quantum will be an accelerator. So this is why quantum will be fundamental for the energy transition.
Thank you, Salvatore. And Francesco, you're welcome to add something. Otherwise, we have many other questions to come.
I guess we have many other questions, but I would just flash one thing. I mean, I totally agree with Salvatore. There is the computing for the, let's say, for the optimization part. Somehow the communication and the the security aspects of the communication might help the resilience of the grid in terms of security. And then, of course, we always have the dream of having new generation of quantum batteries and quantum solar cells, where actually you have a quantum advantage in the storage or in the thing. But this is something for the far future. I totally agree with Salvatore. Now we are more at a stage where the new quantum computing capabilities embedded in classical supercomputings are going to tell us how to manage the logistics of a grid, of a complex grid.
Very important point. Thank you very much, Francesco. And we jump to the next question that is about the SREA. And the question from an anonymous person, unfortunately, asks, does the SREA prioritize between the different pillars of quantum technologies like simulation, computing, etc.? And is there any indication which member state has certain strengths in certain technologies? How will member states be coordinated around the priority and policy recommendations?
Okay, so as split in C, so if we have to prioritize between the pillars, meaning communication, simulation, computing, and sensing, the answer is no. I mean, the four pillars are addressed together with all the others, and there is no priority. What we have done, if you take computing, for instance, what we have analyzed, going from the bottom, in the quantum processing unit, to the driving electronic, up to the algorithm and all the intermediate software stack, we have identified for the different technologies, semiconductor, superconductors, cold atoms, for all technology, we have essentially identified where we are, where we want to go in order to be able to bring a competitive advantage, what are the technical challenges, and what are the recommendations coming from the scientific industrial community in order to make sure that we are address them correctly and in a coherent way with what the other initiatives are expecting. We are not making any difference between the old chapters or pillars are equal in terms of the way they are treated. I mean, computing is of course a bit larger, just because today most of a larger amount of funding is going to computing. Probably the section is a bit larger. And in terms of who has strengths, we have discussed the national initiatives as well, saying who does what. I mean, we know that in Europe, not all countries are investing equally in quantum technology. So we know that there is a leadership from Germany, from France, from Holland, from outside the EU27, from the United Kingdom. But there are other countries that want to progress. So you have a picture of how much countries are investing. Leadership is not expressly in the document, and so the document really wants to say where we are, where we want to go, what is the path to get there, giving recommendations for the Commission in order to make sure that the future calls and the future programs are aligned with respect to what the community says that is needed.
Great, thanks a lot, Salvatore. Francesco, you have any addition regarding the difference and diversity of countries' participations?
Well, it is, I mean, Europe is Europe, we all know it. And so countries have different sizes and different ambitions, and also different ways of expressing these ambitions. So certain countries have announced programs, 10-year programs. Italy, for example, have stayed on a shorter program. We have a 3-year program that invests, let's say, a few hundred millions of, unfortunately, the sizes are these kind of dimensions. I'm not going to talk about the Italian programs here, What I'm saying is different countries are prioritizing, as Salvatore is pointing out, different aspects, whether more, some have embraced the full swing towards a more industrial takeover. Some others are still balancing with substantial aspects of investment within the research part. And so this creates a difference. But what is, I think, important is the effort that we are trying to do to keep it coherent. It doesn't mean that everybody has to do everything. It means that we would like to have a coherent effort where we will have the emergence of some areas where we will focus, but in other cases, Salvatore pointed out this quite correctly when describing the agenda. We want to have a collaborative and collective effort to go towards these technologies.
Great. Thanks a lot, Francesco. I will continue asking you a question which was addressed specifically to you, and it is from Matteo Mascagni. And he's asking you, dear Francesco, from FP6 Atom Chips. And you have been always involved in important Q projects like S-Quant, Malaysia, and others. And the EU policy has changed a lot. So do you prefer, from your personal opinion, was it better the way it was Malaysia's fleet call, or the new types of quantum calls that are available? Please, it would be very interested in.
First of all, thanks a lot to Matteo for this. He knows it quite well because he was my project officer for Malaysia, and I learned a lot from him actually. How to run the projects. It was quite an experience. I think it's an inevitable change. I mean, when I started, and this means simply that I have a lot of gray hair, these were really scientific endeavors where the technology was really low. Plus, the EC also didn't have a policy to take scientific results and feed them into technologies. So this was something that happened within the FP7 and the Horizon and H2020, where the EC started to put in place these programs like the Flagship to emerge from lower TRLs and bring them into industrial level. So I think for a given field, it's a little bit inevitable that you follow, if you are a successful field, that you follow this trajectory. You start with very nice, sorry, my heart is still in the scientific project. So if the question is like that, yes, I still like the scientific endeavors, but I very much appreciate the existence of these new and novel approach like the EIC, for higher TRLs, more involvement of companies. It is not so easy because it's much more complicated. When I answered the first question, it's much easier to collaborate on science. Everybody's ready to collaborate in science within countries, even if the countries are competing very hard. When you start talking about technology, it becomes much more complicated. That is why the effort on these research agendas is essential. This effort where we try to have a collaboration within different industries in different countries in Europe. It has to be clear to all the countries that there is advantage for everybody. You are not feeding money into someone else's technology and they will reap all the benefits. We are all going to benefit. We have to make sure that this happens. But this is the effort.
Thank you very much, Francesco, for expressing your personal point of view. It's very valuable. Now I will do the following thing. We have just one question appearing at the last moment, and I think it's very important, but I would like to read it together with another one. So please, Francesco and Salvatore, pick the one you like more and start from that. That is to your choice. So one question that I really like to address now is from Roberto Magani, And he's asking, how can Europe encourage collaboration between governments, research institutions, and private companies to develop and deploy the QCI? This is question number one. And the question number two, which is very correlated, of course, it is from anonymous attendee, as I cannot see the name. And I suppose this is from the European Commission, because they got the link, the direct link at last. Could you tell us what works for the moment on quantum technologies, and what don't, and what we can improve in the sector? So I do think it's from the European Commission, so please read it as if it is from. So these are the two questions, and then we close the session.
I may say a couple of words about the first one, probably. The second one is a bit too broad, I would say. I think, how can Europe encourage collaboration between government, research, etc.? I mean, these what EuroQCI, for instance, is about, and what the flagship is. Today you have initiatives within, we mentioned, within all countries where they are developing their own test beds for communication, their own infrastructure for, I mean, this is QCI, but it applies for me to the others. They're developing their own test beds. So it is fundamental that at certain points we can pass the border between countries, and this will require standardization. It will require common knowledge sharing, that what is being developed in one country is being exploited in the others in terms of everything from sources, detectors, infrastructures, and that we develop a coherent and optimized network within Europe that can only be done if national initiatives are coordinated and consolidated at the European level. The same applies for all the other initiatives. If you go into quantum computing and simulation, if there is no coordination at the European level, giving access to these facilities, we risk replicating and having everyone developing his own HPC facilities with the same accelerator inside, spending time, effort, and money working on all the stack from the hardware integration up to the top level software algorithm. So you need to create a system where centers and facilities that can develop knowledge, share technology, and can be done at the European level, based nationally. I mean, they have to be based nationally, but they have to be developed in a coherent way at the European level with funding. There should be a hybrid form of national and European funding. So Europe has a fundamental role, because no one, I think one important point, that no one in Europe will do anything that can be comparable with what China and the US are doing if we stay at the national level. Europe is the level where technologies, quantum technologies, have to be played. If we do it at the national level, we will lose. So there is no way. I mean, I don't know if it is everybody shared, but Europe is the place where this battle will be won in Europe. And if we align, thanks to the European Commission, if we can align national initiatives with granting that are aligned in terms of strategy, in terms of fundings, and so it's fundamental. We are not going to do it. We are not going to do anything competitive worldwide if we do it at the national level.
Mute.
Sana, you're muted.
Thank you very much, Salvatore. So he picked up the question first. Now, Francesco, you are ready.
Now I have to answer the impossible one. So this is, of course, it's very good, because you will principle quote me, because I will be clearly and obviously wrong. So when we wrote the agenda to start the quantum flagship, the thing we were thinking as the really last thing that will appear were computers. And now the hype is very much on computers. And I think the drive there is not because we are now close. Sorry, I should say this. It's not because we are now closer to a quantum computer than what we were a few years ago. It's just that there is an enormous body of understanding of what we would like to have from the quantum computer. And this comes not from scientists, but especially from the users. We have understood that these simulators and intermediate computers can be useful. We don't need to build a universal quantum computer, can be useful as accelerators. So I think this is an example of a technology that we as scientists thought was very far, but and it may still be far, the universal quantum computer, but you can put it into a different context and already use it. Sensors are here. We are getting sensors. They might not exceed the some classical sensors directly, but it could be less invasive. Communication, the quantum key distribution is a reality. The quantum internet is not, but it's an effort. So that is a more long-term. Quantum internet is definitely long-term. Repeaters probably will be here within 5 years. So if this happens, then we are a long way on. Quantum batteries and quantum solar cells, although I'm working on it as a scientist, I'm not sure. They may be more far-fetched.
Hi, everyone. Thanks a lot to both of you, and sorry for jumping in. I'd like to try to summarize many questions in one, because the time is running. And so essentially, for instance, there was a question about programs on how EU Flagship coordinate all these pillars with national security agencies, military and NATO, etc. And maybe there's, on a similar note, also another question by Ferdinand asking, essentially, these are more political issues about how can we go from competition towards collaboration on an infrastructure blueprint for quantum technology. So essentially, how can we really go from the fundings on research to something that can be profitable for security agencies or for national interests and European interests in general?
Well, so you want an answer on that?
A comment, let's say. A comment.
No, a comment. Well, possibly I will leave a little bit later to Salvatore to elaborate on the collaboration, because there is an important chapter there on the agenda for that. I mean, there is an effort that the EC has already been doing with the hubs that is not, okay, I take responsibility for what I'm saying. In my opinion, is not paying off that quickly. And this means that we need to rethink a bit our way of collaborating, in the sense that we need to understand that when we want to work with companies, trust is the fundamental issue. The company should be able to trust let's say the wrong word. I'm saying the wrong word. The knowledge provider, the academics, or the research research entity that is giving them some technology, but there is a need of trust there. It can't happen as we cannot replicate directly what was done with the research institutions, because there everybody knew each other. This is a more complicated world, so we need to have people collaborating, being closer to each other, no matter if they are in the same country. They will have the possibility of connecting to other countries, and this will lead to a European effort. But we cannot impose, as we did with research, I'm talking about rules like you have to have one research institute from 3 different countries and so on. This for technological development is a little more complicated.
Yeah, but what I can just say, just with respect, there have been lots of comments in the. So to me, the system is not perfect. I mean, this is what it is. Europe is not perfect. There are national interests that are there. They will remain there. So the best, I think, what we can do today is to make sure that we are working together. That today, at the that Europe can push discussion between different national representatives, for instance, in quantum, and can introduce this in the governance of the European or the European flagship. That should be hopefully be done in the future. That would be something good. But anyway, this is the way it works. I mean, things are done nationally. There is standardization and that is developed at the national level. There are interests that are national. Even in terms of volume, Europe represents probably 20% of what is done if you take the sum of what is done at the total of the E27, which is dominated by a small number of countries. So the situation today is there are national interests, there are national programs. Europe has to do the best to make sure that there is the only place where different countries can discuss, where interest can be put in a transversal way as the funding to do it. And I think we are doing it in a fair way. I believe that the transversal initiatives and infrastructures are there, international, transversal to Europe. The roadmaps are as well. It's not perfect, but I think it's going in the right direction.
Yeah. Thanks a lot. This was a marvelous session and a lot of questions. We couldn't answer them all, but we'll try to pick up maybe on the next session as well, because they are all actually related to another one which was asked by let me check, by Ferdinand as well. Ferdinand is by far the champion of the questions today. And the question that he asked, I'd like to use as a closer for this session, which will actually announce the next session one more time. And he asked, how is the responsible research and innovation involved, and actions on the ethical debates on quantum technology? And I think in this endeavor, we would actually find a lot of support to the questions that we already asked. And I'm really happy to say that in Europe, there is moving a little network is being born, let's say, on these matters. And they are hosting already 4th conference, which is called Responsible Quantum Technologies. And in this conference, they are trying to put together quantum technology producers and the philosophers and lawyers and social scientists to discuss on these particular questions. So I'm really glad this question is raised, and I'm even happier that next session we are going to address specifically this one. So on this coherence note, I would like to thank our speakers very much for accepting the invite and giving this wonderful contribution. And I look forward to see you all at the next session. Now I will stop the recording, but please don't run.
Thank you.